Next, I ask you to run an OLS 100 times, each time on a new sample that we simulated. To do so, I ask you to create a function called estimate correct OLS, and then apply it using map function. So first of all, with the function, when you want to specify a function in R, you put a name of the function and you say function. You put all the arguments that it should get from the R environment. So for example, data, model, and so on. So it could be different things. And then you open it up and specify what you want to do with the data. For example, you want to have a function that selects column D. So here, your name of a function is estimate correct OLS. The object that you would be supplying, it's an abstract name. You provide an abstract name. It could be X, it could be I love Tilburg, or whatever, right? So it's just a name to which you then, when you would want to estimate correct OLS, you would say I love Tilburg equals dataset, for example, right? So this is something that you will have to supply in terms of the name of the actual object that you have, and this is its nickname that will be used within the function. Now let me return back the nickname to df. Inside the function, you run a linear model, and you know that you will supply the data sets, 100 of them, and each will have y, d, and then these variables. Now we are estimating correct OLS, and that is why we already put the correct things that actually impact our y. Our y depends on d, our y depends on v1, v2, and v3, but it also depends on v4 up to v9. So we say, okay, once you are running this function, run a linear model of y on all these variables that are important, and we know for sure that they are important because we know how we created this data. And what should be the data that should be supplied for this linear model? It is df that we get from outside of the function. Then we ask to tidy our output so that it's a data frame, and since it's a data frame, we can always filter the terms. For example, we could have filtered, please return back only the rows that correspond to v1 or rows that correspond to v2. No, we only return the row with the estimates of the OLS that correspond to d. So it will return back the coefficient, the p-value for d, standard errors of that estimator. So, and that's it. When we are at here, it will be a data frame with just one row, and we ask this function to return back the data frame. You can simply see that, for example, we take simulated data. The very first sample that we simulated is this. So this is the first sample that we get. Now, if we run function estimate correct OLS, where we supply the data frame, this very first sample that we simulated, you see it returns us back only this row. Now we apply this function using map dfr. So we save it as true results. What would be the class of this object? It will be a data frame. Why? Because we apply a function estimate correct OLS where df, remember the nickname df, will hold actually one of the samples that we generated. Remember, to access the first sample we have to put 1 here, to access the second we have to put 2 here, but we are putting a placeholder of x, where this is a counter that goes from 1 to 2 to 3 up to nsim, in our case 100. So once you apply this function, it will iterate from 1 to nsim, estimate correct OLS on a new sample of observations. And then in the end, what you get is data frame rows, which map automatically glued to each other into one data frame. So in the end, results true will be a data frame of 100 rows, a result of 100 iterations. Finally, we want to plot our estimates. And since we were going to use plotting those simulated estimates many times, I also made it as a function. This function takes an object, which internally it's called df. It takes df inside this function, and this code generates a density plot for the column called estimate. And this part creates a vertical line which indicates the true treatment effect. So here we put plot estimates, and we supply results true, which then will plot the density of this column. And this is the plot that we wanted to have. Okay, amend the code below to get the mean and standard deviation of the estimates that are stored in results true. So we take results true, where we stored our estimates, and we summarize. We want a mean of estimate and then standard deviation of estimate. Now I ask you to run again naive post-last estimator 100 times. So we just take our code before that we did in the simple post-selection inference in this section. I just copy-pasted the code. So creating matrix, cross-validation, running lasso at the best lambda, then storing the lasso coefficients and filtering those that are not zero, and then running an OLS on the treatment and selected controls. This is all the code that we already saw as applied to one data set, which we call data set. But here we say apply this function, and this function is written as if our data set is called data. And we specify that data is actually something that we pass to our function when we call for this function. Now here we should apply the same function we applied for running OLS 100 times. We applied to run naive lasso 100 times. So it's map dfr.x. So our counter goes from 1 to n sim. And here we specify function, which is estimate naive lasso. And as a data, so as you can see, we just repeat exactly the same code as we did for OLS, running it 100 times, but we substituted the function. Now we're calling estimate naive lasso. To plot estimates, we use again the same function called plot estimates. This was and plot the results naive lasso, and then we summarize mean results naive lasso estimate and standard deviation estimate. As you can see, our lasso estimates are actually centered around 10